This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. I look at this and I ask myself, is there anything that I can strip away? Because if there is, then I am able to find a sequence that I can compare to, and I might be able to use a comparison test. So I look at this and I'm really looking for, as n approaches, so as n gets really big, what becomes insignificant? Well, this plus 1 would become insignificant because what is adding a 1 to infinity going to do? Nothing. So I can strip this away. And this n to the 5th power is also going to become insignificant because we have n to the 7th, and that is going to be bigger. And infinity is just infinity, so we can just get rid of these two as well. So because I have an idea of things that I can strip away, I'm going to try comparison test. So because I can see that I can kind of strip things away, I think it's a good idea to try the comparison test, and I always try direct comparison test first. So the rule is if your sequence A of n, so this one, is less than or equal to the B of n sequence that you're going to come up with, and we'll talk about that, and the series of B of n converges, then you can say that the series you were given also converges. And then you just take the opposite sign. So greater than or equal to, this becomes diverges, this becomes diverges, and then everything else you drop down. And then remember, for DCT we use IBBCC. So I stands for information. So this is information that we know and information that we need. What's something that we already know? We know that our A of n is always our given sequence. And then what's the information that we need? Well, we need our B of n, the sequence that we're going to compare A of n with right here. So then that intuitively comes to the second step, which is find your B of n. How do you do that? Well, this is what I was talking about stripping away. You say at large n, and then you take your sequence up here, bring it down, and you ask yourself, what does it become as n approaches infinity? That's what this means. Well, again, we said that if you plug in infinity to these, what is a plus 1 going to do? Nothing, so you can strip those away. And this is already infinity, so you don't need this either. And so in the numerator, we're left with n squared, and then in the denominator, we're left with the square root of n to the 7th. So this here becomes your B of n. Beautiful, now we have everything that we need to solve our problem. So first I'm going to check the behavior of the series of B of n. So you're just going to take the series, whatever you see here, you copy the same, so n is equal to 1 and then infinity. You're going to take your B of n, which you found, bring it down here, and then for this, you're just finding if it converges or diverges, and you're always only going to use either the p-test or the geometric test. I think I wrote a 2 here, that's supposed to be a 7. So you simplify, so this becomes n squared over n to the 7th halves. So you keep the 7, and then whatever root here, you divide by it. And then same base, so you can subtract the exponents since it's division. So 2 minus 7 halves, that's 2. 4 minus 7, negative 3 halves. So that means we have 1 over n to the 3 halves. That means you have your base and the negative 3 halves, which just means 1 over n to the 3 halves. And then I see that this is in the form of a harmonic series, a p-series, where p is equal to 3 halves. So I'm going to choose to do test, and the way that I remember the rules for p-test is the movie rating PG-13, so p is greater than 1, and then this is kind of like a sideway C, so converges, and then the opposite signs are true. So we said that p is equal to 3 halves. Then we want to know, is it greater than or less than or equal to 1? Well, if you have bad number sense, you can just divide 3 by 2 just a little bit, so you know it goes into it at least one time, so it's obviously going to be greater than 1. So p is going to be greater than 1, so this series converges because p is greater than 1. So we have that our series B of n converges. That is the behavior of B of n. Beautiful. Now we move on to C, which is the comparison part. So you're going to take your A of n, and then you're going to take your B of n, and here's the thing, you might have simplified over here, like so, and then made that your B of n, but then it would be hard to compare 1 over n to the 3 halves, so use the unsimplified version to compare, and the simplified version to find the behavior of B of n. That's my little tip for you. So then how do we compare? Well, I look at the numerator, these are basically the same. A plus 1 isn't really going to do much in the long run, so assuming these are the same, you look at this, they both have a square root of n to the 7th, but this one has a square root of n to the 7th plus more stuff. So this denominator is bigger than this one, and because you have essentially the same thing, but here you have that same thing but divided more, then you're making the whole thing smaller. So this is smaller than this. In other words, A of n is less than or equal to B of n. Beautiful. Now, because we know that this is true and this is true, we can conclude that our given series, A of n, converges. And so we're done with this, and now we get to our conclusion. So I would start with since, and then I literally just copy the sentences that I wrote. So I put this over here, and then I just copy this, move it over here, and we say for all n greater than or equal to whatever number you see here, so that's 1, then direct comparison test implies that our series converges. And that's it for this video. I'll see you in the next.